Vice Provost and Director of the USC Emeritus Center, for her assistance in advertising today's program. And the Retired Faculty Association could not function without the Emeritus Center and Jeanette's unfailing support. The USC Emeritus Center has been collecting living histories for many years now on film, video, and audio recordings of our distinguished faculty and staff for the university's archive. And this past September, the RFA board adopted a new initiative called Intellectual Journeys. The retired faculty will share stories of their academic careers. They will explain why they became interested in a subject or area of exploration and talk about why they spent decades thinking about, writing about, and teaching about their chosen subjects. Greg Thalman, Professor Emeritus of Classics and Comparative Literature, will host today's Intellectual Journey. Greg, will you please introduce our guest speaker?
Yes, thank you, Jerry. If you go to the website for what's now a Department of Quantitative and Computational Biology, you will see a picture there of Michael Waterman teaching a class. And it's one of the most eloquent pictures I've ever seen. He is gesturing, he has a big smile on his face. The students are captivated. And that picture really confirms what I already know about him, that he, aside from being extremely distinguished in his field of science, is a wonderful teacher and mentor of younger people. And another sign of that is that, in addition, as only one of his many contributions to USC, he served as faculty master at Parkside International Residential College. I can introduce him by talking about his formal attainments and his many, many honors. But I also want to mention that in addition to all his very distinguished scientific work, his pioneering of the field of computational biology, quite in addition to being a fellow of the American Academy of Arts and Sciences, a member of the National Academy of Sciences and of the National Academy of Engineering, and a foreign member of both the Chinese and French Academies of Science, in addition to being a university professor emeritus. While he was doing all of that, he is also an avid hiker and skier and lover of the outdoors and of nature. And if you go to Amazon and do a search for him in books, you will come up with two titles, one called Getting Outside, A Far Western Childhood, and the other In the Gila Headwaters, which he has chosen for his background today on Zoom. So it's a great honor and a great pleasure to introduce Michael Waterman to you, though I don't think he needs any introduction to very many people. The format is simple. He will say whatever he feels he wants to say about his career and his life, and then we'll just open it up for questions and discussion. So we hope to make this as interactive as we can. So Michael, thank you very much for doing this and for us and for being here. So over to you.
Okay, thanks, Jerry. Thanks, Greg. I thought for a while about how to frame this, and I'll stumble through my life and try to pick out sort of pivot points. In statistics, there's a concept called change point, where you are observing the results from a stochastic process. When does the underlying distribution change? So I'm going to try to find like pivot points that do that. And I sort of have to start with my rural childhood. It was quite isolated. There were no there were no other children that I had any interaction with when I was a kid. The nearest house was my grandfather's. It was a half-mile away. And it was mostly about just work. My father explained to me more than once, would he get enough labor out of me to balance what I was costing him? And if I ever asked why something happened, it just pissed him off. And the first sort of journey somewhere else was when I was in third grade, reading some book about the first time I escaped through literature. It's a book about Daniel Boone, a pioneering story, and it just took me out. And it was like, how could I get more of this? My family didn't have very many books. The library was quite slim, but I read everything I get my hands on. And the real transformation came in the 7th grade. My mother bought me, maybe it was the smallest, the next to smallest, Gilbert chemistry set. For the first time in my life, I realized people understood something about how the world was put together. It just set my brain on fire. I could not get my hands on a decent chemistry book. The high school chemistry teacher in this little town was the coach, and I could tell from my interactions with other people, he didn't know what he was talking about. But I decided my goal in life was to be a chemist in Chicago, which was about as far away as Mars. And also the great thing that year, my teacher, Mrs. Churchill, was the first teacher I ever had who actually liked me, I think. She had red hair, a wicked sense of humor. And that plus the chemistry thing really, really got me going. And I have to say that when I took algebra, I had a decent teacher. When I took algebra, that abstraction, I really loved that. I didn't like the work of adding numbers and carrying and so on, but moving the symbols around that you could understand more if you abstracted it really got me going. And I went to Oregon State. And quickly, I found the library. And I had thought until that time that I would run out of books I was interested to read. And I went in to the library and I had to sit down on a bench. I was so stunned. The problem wasn't running out of books, but how to sort through them. I took lots of lit and philosophy. Math was easy until I took a graduate class when I was a junior, and then it wasn't. My main mentor as an undergraduate was a crusty English professor named H.E. Childs. Bernard Malamud had been at Oregon State for about a decade. He left during this time. And Childs was satirized in Malamud's book, A New Life, which was pretty cool. So I got a bachelor's and master's there. And my goal was really to find a job that was fairly secure, that didn't involve a lot of dangerous manual labor, and somewhere near trout stream. So, okay, could I get a job in a small college near a trout stream? And you could then with a master's, but somehow I sensed that wasn't going to go on forever. So I went on for a PhD and went to Michigan State, where I had what was the perfect advisor. He was just didn't follow normal paths, and we really got on. And when I got my PhD, I had done in that time 5 publishable items, and in those days was my master's thesis. In spite of my advisor who didn't advise me. Was suggested that was publishable. When I was at Bell Labs, my supervisor asked me if I wanted to submit it, and I said, why would I do that? But when I got the PhD, I did felt like I owed my advisor, and I submitted that, and then my master's thesis as well. And you look at that, my career was definitely set then, but I didn't know it. So my job search, which really irritated the Michigan State Statistics Department, was the school was in the Rocky Mountains and did not have a PhD program. And I found one in Idaho State University in Pocatello, Idaho, and I spent the happiest years of my life there. I did go to, and I remember that first winter, to my shock, I walked over to the student union with a reprint and a pad of paper and started working on something. And why am I doing this? I thought, and it went on from there. My advisor's, I was his second student, and his first student was at Los Alamos. And so I ended up going to Los Alamos in the summers for a while. And it was still an intellectual aristocracy. There were some just great people still there. And I finally decided to go there full time, motivated in part by the energy crisis that some of you may remember, but also there was something called the Idaho Academy of Sciences. I would go and present something. And one year I went and I could hear people, what's he going to talk about this year? And I thought, you know, I need to be somewhere where there are lots of people smarter than I am. And so I went to Los Alamos, where through one of those great people there, I discovered this emerging area of DNA and protein sequences. We're just in the 70s, just, you know, Crick and Watson knew about DNA, but you couldn't read it in any volume until the mid 70s. So, you know, when you have text like that, you can do things with it. And there were like wonderful, motivated new problems that came from the biology. After a few years there, somebody at the University of California, San Francisco wanted to hire me, or was interested in hiring me. And I didn't think I was ready for that, but I went as a visiting professor. And that was before any of those faculty members were president of the National Academy of Sciences, or they had Nobel Prizes. This was a seriously motivated group of people. And I went to every biology talk, finally really learning a little more biology for myself. Mark Katz, the famous mathematician, came to USC during that time from after retiring from Rockefeller. And I was one of the people he recruited. And I was here a little while. And in 1985 at Santa Cruz, let me back up a minute. If you look at normal descriptions, the Human Genome Project started with a meeting in the spring of 1986. But in the fall of 1985, a dozen people were summoned to Santa Cruz to talk about, could we sequence the human genome? I was the only person with any computer science or mathematical science, and it was a marvelous few days. And I wrote a little paper describing this, the Human Genome Project, the beginning of the beginning. And just recently at USC, a visitor gave a talk, and they had the end of the beginning. So keying off my title, I guess. So California Magazine wrote about this meeting, and I was described, not with a name, I was described as a computer person from USC. And I treasure that, I really do. And the Human Genome Project really propelled me into giving many more talks and being an evangelist for bringing in mathematical and computer analytical science into genomics. And it's an incredible honor to be just in the vicinity of what's one of the greatest scientific projects ever will be in human history, that we could look at the very material that our ancestors handed down to us. I think would have been worth it if there were no medical advantages or anything else. I mean, what a thing to be involved with. And I guess maybe the moral of all this is there's some value in not following hot trends of the time, but following your heart, your abilities, and your instincts. So anyway, I'll stop there and answer anything anybody can think to ask me.
Thank you. Yeah, please, you can use the raise hand tool, or you can ask a question in chat. I will try to keep track of it. But does anyone have a question to lead off?
I do. Coming from career services for years ago with our students, and I see a few students on the line, knowing what you know now, I think you just gave great advice. Follow your heart, and maybe don't feel like you have to go exactly the way everybody says you have to. But are there any other tidbits of advice, and what would you say to our students now who are undergrads and graduate students as well?
Yeah, it seems now I brought up that aspect of having publishable items that weren't ever published. You did a job search without publishing anything. And today, the graduate students are frenetic about getting lots of publications. And I think that's not necessarily the most important thing. It's important to do really good work. But I'm not quite answering your question. We started this new undergraduate program in quantitative biology, and essentially it's attracted students who were interested in the biological sciences, but also interested in the mathematical and science and hard science input into that. And these kids, we've always had some of them at USC, but they've just been an inspiration to me as I'm ending my career, seeing this group of really motivated students who complain if a course is too easy. And, that's not really advice, but that was inspiration to me that these kids were around.
Good. Anyone else have a question?
Yeah, I have a comment that's sort of an observation. And I've mentioned this to Michael previously, that when I came to SC, I got to know Steve Sample, and he became something of a mentor for me. And he said to me once, we have a lot of good faculty at SC, and then we have some great faculty, and we really don't want to lose them. And he said, normally when Lloyd and I talk to those faculty and we say, what's it going to take to keep you here? They usually want a raise or they want better parking. And he said, but then there's this guy, Michael Waterman. And he said, when we talked to him, he said his students needed better research labs and they needed a new building. And he said, that really impressed me. And he said, if you want to make it here, you should get to know Michael Waterman. And I did, and I'm better for it.
That's mutual, Bill.
Thanks, Bill. Anyone else have feel free to make comments as well as ask questions. Well, if no one else does, I have a kind of obvious question, and that is how you fixed on computational biology, because my impression is that this was not an obvious path for someone starting out in biology when you did, and that you kind of made your own path. So was this your interest in mathematics and your interest in biological science, just combining them, or was there something else that, I mean, what really made you passionate about this?
I mean, back at that time when sequences were first coming out, of course, computational biology didn't exist. And there were probably me and David Sankoff from Montreal were probably the two real mathematicians who were really devoting themselves to this. And it was just the problems. Initially, I wasn't interested in the biology per se. I was interested in the problems biology gave me. And I remember the great Stan Ulam said, do not ask what mathematics can do for biology, but what biology can do for mathematics. And for me, it did a lot for me. And then, I mean, at UCS, I got really keen on the biology side. I didn't take biology classes in college. So yeah, and I just sort of wonder. And the name came when I finished a book in the mid-90s. And what was I going to title this book? And at the University of Chicago, there had been a sort of a school of mathematical biology that had sinned so egregiously that the biologists hated it. So I couldn't call it mathematical biology. And I looked around and thought computational biology was a general enough term. And so that's where the label came from.
So you actually named the field.
I mean, it wasn't that people weren't doing computation in biology and so on. Yeah. I will take credit for that small niche.
Doesn't seem so small to me.
Well, today it isn't. There are just so many people doing such deep and complicated work.
So where do you think the field is going to go then?
Well, in the 60s, I guess, around that time, early 70s, Barry Commoner had this line, everything is connected to everything else. And of course, that's pretty obvious today with social networks and so on. But in biology, everything is connected to everything else. I mean, who knew before not so many years ago that we had 10 times as many bacterial cells in and on our body as we have cells with human DNA in it. They weigh about 2.5 pounds. So you can subtract that if you want to. But our health, ill health and good health is connected to that. And all of this microbiome in our gut that affects our brain, our depression, and moods, who knew this? So there's this incredibly interconnected, complex, that's life. And, the problems when I came to them were simple. No one knew what they were, but they were simple. Today, it's not simple. And there are people branching out into diseases, army of people trying to understand cancer. So it's diverging and getting so complicated, and eventually you won't be able to tell a biologist from a computational biologist, I think.
Great. Anyone? I've been just going on. Does anybody else have a comment?
I actually see the name Maria Pellegrini on the screen. Although I don't see her face, I believe Michael and Maria actually you overlap. And I'm here trying to see if Maria has any comment, because she certainly has something to do. Before she left the USC to UCLA, she has something to do with the Michael's career at the USC. So I'm actually trying to see if I can manage to get Maria on board to say something.
Maria, what about it? Can you?
Well, I'm trying to get my video going here.
Here you are.
Yay.
Yeah, it's nice to see the face that we recognize many years back. Yes.
Yes, still here at my kitchen table, which is where I still work most of the time. As many of you know, I have been off and on with the WM Keck Foundation, where I still am serving as the executive director of programs. But yes, I remember very well when Michael came to USC and started proselytizing about this brand new field, and started meeting some people who he brought to campus. And I actually was thinking, and maybe Mike, you would be willing to say a little something in a minute about the Smith-Waterman algorithm, which was one of the very, very first to sort of get people going in this analysis of DNA. But I want to share one anecdote, which I still remember well. And it turns out that a guy named Walter Fitch and another guy named Mike Waterman decided to come to a developmental biology course that I was giving. And having two National Academy members sitting in the front row was breathtaking, shall I say. Scared me to death a couple of times a week to go in there. In any case, I survived. And I'm going to turn it back to Mike if he would mind talking about that early and still famous algorithm.
Well, Maria, neither Walter Fitch nor I were in the National Academy when we were sitting in the front row.
But you were about to be.
So this algorithm of Temple-Smith, I took a leave from the lab and was at Temple's University in Northern Michigan. And he went away to a Gordon conference. And we had been doing sequence alignment, where you try to trace the relationship between two protein sequences or DNA sequences. And what Temple came back with was that something called introns had been discovered. And before that, we knew about genes in bacteria that start amino acid by amino acid coded and stop. And with all of us, our genes are split up with stuff between them. So there's the gene, and then there's these intervening or introns that get chopped out and thrown away. And we immediately knew that the algorithms for comparing sequences that we've been doing would fail miserably on sequences of the introns. What you had to try to do was find the pieces of the gene to match them. And we didn't know what the problem was. And we were maybe a couple of years trying to come to grips with this. There had been another solution by a guy at Rockefeller, but it was incredibly involved and not effective. And finally, there was just this clever little fix to the algorithm we had been doing that made it easy to code. And even then, my advisor had the concept of the right answer. And of course, there's the right problem too, which I think he just assumed. So this was the right problem, although we didn't know what quite it was. But after we did, people didn't immediately take this up. And so Temple went off to other things, but I proselytized this algorithm for a while until everybody realized it was sort of central. It's key to doing searches of genetic databases like Google search. Only our algorithm is computationally more expensive, and there are very famous heuristic algorithms that use ours in a subroutine to do this. So when you have a new organism that you sequenced, you run it against known this huge library of known sequences to find pieces that match up, and that will give you clues about what the function of the current genome is. So it's a search algorithm, and I never imagined that I would be involved with anything that would be in textbooks and stuff, which is kind of neat, actually, I admit.
Anyone else?
Yeah, maybe, okay. Okay.
Go ahead, Richard.
This may be a strange question, but
during your early parts of your career in your life, how much did serendipity play a role in your life choices? You just happened to be curious about something and something came around the corner and attracted you more than anything else.
Yeah, I mean, part of it is the machinery you've accumulated along the way too. To notice, oh, maybe I could do something with that. And I recently heard a description by a friend of mine who'd done some research about growth of neurons or something. And I mentioned it to a biologist friend who immediately made it more complicated. But of course, I'm a mathematician. I made it much more simple. And it wasn't until I was telling this story to Simon Tavares, and then his eyes lit, he got it immediately. So there's different ways of approaching problems. And so anyway, if I hadn't gone to Los Alamos, I would never worked in this. I would never worked in this field, for example.
How about those early years when you were in high school and whatnot? That's where serendipity plays a big role in our lives.
Yeah. Yes. Well, most, the great thing about school for me was I could rest up from the weekends of labor.
Yeah.
I would get to class on Monday, and I would not pay attention until Thursday. I'd just be resting away. Okay, what are you guys doing? But there was, of course, a little school, and there weren't, other than Mrs. Churchill, there were two other excellent teachers I had. One of them was my math teacher. And the last one was my senior year. The coach was teaching literature, but he got the home ec teacher pregnant. So immediately they sent her away immediately. And as soon as they could, they recruited a PhD student from the University of Oregon to teach lit. And that guy set my brain on fire for lit. I mean, he was great. He was just tough and pushed us. So I mean, and you see two passions in my life, math and literature. So they were absolutely good teachers. You don't have to have many good teachers, but you need a couple.
Right. Yeah. A couple of models. Yeah.
Yeah, well, I know you write poetry. I know you write stories. Could you talk a little bit about that?
Well, the Getting Outside book was really just writing my childhood. So I hoped it would get it off my back. It doesn't really do that, but at least it's down in print. And the book of, whether they're poems or not, you would have to tell me. But the book of poems about the Gila came, I've been there so many times. And one year as I was entering, there was a reward for finding somebody who'd shot a Mexican gray wolf. And I had no idea that they had been reintroduced into the Gila. And it just got me thinking. And I was going to take notes on my hike, and I had a narrow little pad. And I started writing stuff down, and they sort of turned into things that looked like poems. And that's where that book came from. It's just all my experiences there just came bubbling out. And I'm trying to finish, supposed to finish another book now that I think it's a little of this and a little of that, but it has some things about USC and UCSF and Los Alamos. I'd written a number of essays about some of the people at Los Alamos. So it's partly built around that. So, the great thing is when you're not writing prose for a living, you can do it when you feel like it. Whereas if you're teaching a class in advanced calculus, you've got to show up.
Greg, I see a question from Feng Su Sun.
Yeah. So actually, I'm Mike Waterman's former student and the postdoc. So I say a few words from that perspective. And Mike always help the graduate students and postdocs, and many of his postdocs are world leaders in the field. And another thing that I would like to say that Mike always try to push us for independence. And I still remember that one of the papers that I joined to work with Mike, and he had some contributions. And then after I become a faculty member, he refused to be on part of that paper, although he made some contributions. So, I mean, that says something that he, although, we don't encourage all the faculty doing this, but he just put students in the front line. So the other things I'm always impressed is Mike can say things that 30 years or 50 years beyond. It's kind of amazing. One project that when I was a graduate student about over 30 years ago, he asked me to work on the so-called in vitro evolution or direct evolution. It's using the mutations, recommendations in experiment to evolve enzymes, that kind of things. And at that time, only very, very few people work on that. And so Mike realized that importance, and that technology got the Nobel Prize about 4 or 5 years ago. Now, and Francis Arnold now it's Joe Biden's top board members and so on. So anyway, Mike also made many other contributions, in particular, like sequence assembly, and he developed the method using the cameras and then to do sequence assembly. At that time, the first few years, and the paper was not really that highly cited, but then now the methodology become the common practice, and everybody uses those methods to do sequence assembly. So, for whatever reason, Mike could just have that ability to say things that many of us only say after 10 or 20 or 30 years after that. Yeah, I stopped from here.
Thank you for that, Mike. Do you want to respond?
No, I won't. I do remember that paper. We published it in 1995, and it was the first. It was how to overlap pieces of sequence DNA together to get the underlying text. It's like you had a New York Times article, and you cut it up into little strips about 100 letters long, and duplicated it many times and stirred it up and sampled it at random and tried to reconstruct the underlying text by finding pieces that overlap. So for 20 years, the method had been improved, like Model T was improved to a Ferrari, but it was still an internal combustion engine with a Ferrari. The same with the sequence assembly algorithm. This is quite a new idea in 1995, and nobody got it. It was just there. And like 10 years later, they absolutely had to go to it. It became standard. So anyway.
Any others? Anyone else?
Karen?
Yes, kind of off of your question, Greg. You've had such a remarkable career. You're such a brilliant person. I just, because we talk a lot about this, I'm on the retired faculty board about retirement. And so Greg got you to talk a little bit about your writing. Are there other pursuits that you have taken on now that you've left the university?
Well, I'm sort of delaying it because I had this not full-time research professorship at the University of Virginia. But that started just as COVID started. So I finally showed up in person a couple of weeks ago. so that's it sort of kept me going, but it's a really good question. And my mode at USC was spend all my time working and then go off into the mountains and hike alone for 10 days, 2 weeks, get everything shed off my back, and then, come back again. And one of the issues with this age is that I can't do those kinds of solo rigorous hikes and so on. I'm trying to come to terms. I don't really want to stay in a lodge, but can I stay in a lodge and find some way to have that part of my soul get aerated? So I'm working on it is the answer. And of course, this non-scientific writing is always something you can fumble around at. Some famous writer's name I forget talked about visiting. Now all the names fall in my brain, of course. A famous writer, a famous older writer, was living in a hotel, a little town in Arizona. And the younger guy came and said, "So what are you doing?" And the older writer described a translation project. And the younger guy said, "But that's not important. That's not an important writer you're translating." And years later, the younger writer said he realized, and this is my paraphrasing, that what it was an old man's project. It was a project to be engaged, to stay busy. It was something, but you're not holding up to try to write a Pulitzer Prize winning novel, but you're doing something. And I think to find those things to do in older age is really, really key. And I'm still fumbling around with that, but at least I know it's there.
Thank you. I would agree with that, finding new things or, searching for areas and things that before were difficult because of time restraints with an academic career has been, to me, very enlightening and exciting. And I'm happy to hear that you are doing these these prose, these writing about your experiences, which are so interesting. Have you been to the California Wolf Center in Julian?
I've not. Huh, Julian.
Maybe that's a weekend trip.
Okay.
It's pretty cool. We were in Julian and looking for things to do, and it was really interesting to learn about the wolves, the gray wolves and the other wolves, and how few there are, and they're trying to replenish them and keep an eye on them, and it's not far.
I will do that for sure. These Mexican gray wolves are endangered. There's a few hundred of them in existence. And on my last hike in the Gila, I'm taking a day off in this little meadow with rough country all around it, sitting on a tree, and a Mexican gray wolf came out and wandered around the meadow. And that's one of the blessings of my life, was seeing this guy. Just thrilled me no end.
They're beautiful. Wolves are really amazing creatures.
I managed I managed to rent a photo of a Mexican gray wolf to put on my Gila cover. So.
Thank you.
So does anyone else?
I wanted to just step back for a minute. And you mentioned in passing the gentleman named Mark Katz came to USC about the time that you connected with a Santa Cruz group and talked about the Human Genome Project. Is Mark Katz the person who attracted you to USC?
Yeah, absolutely. Mark, so Mark's good, was a refugee from Poland, one of these great mathematicians, and had spent his life at Cornell and then Rockefeller. And his good friend, Stan Ulam, was at Los Alamos, and I was close to Stan. And so I met, Mark was very urbane, but I did meet him once or twice at Los Alamos when he was visiting Stan. So I'm at UCSF. I know I'm not going back to Los Alamos. I had no idea what I was going to do afterwards. In a little cubby hole, I mean, the medical school there is just, it's a war. And the phone rang, and it's Mark Katz. And he says that another mathematician we knew had said I was leaving Los Alamos. He was really surprised I was, but if I was leaving New Mexico, I should come to USC. His job was to build up the math department and come down and see what he was doing. And this was a guy you could not say no to. And he described once to me that his job was to build a math department at USC that the football team would be proud of. But yeah, I think the people he brought, I think, energized the math department without any doubt. He didn't live too many years. Past that, he just had colon cancer when I came, and maybe 3 years, 4 years, most 4 years later, he died. But he was a magical person.
Thank you.
So I have a question that's kind of the inverse of Karen's. That is, during my career, I constantly was short of time, and just how to fulfill all those obligations, the teaching and research and things was a constant strain. And yet you've been able to have this wonderful scientific career and take 2 weeks and hike in the mountains. How did you do that?
Well, if you're not there, they can't do anything to you. And the great thing with the mountains, the phone doesn't ring.
That's a great way of putting it. But didn't you sort of fall behind in your academic work when you did that?
Maybe, but it's some of it's about having ideas, some of it's about trying to carry things out. And, you need to decompress a few times. I mean, it isn't like every month I was going off for 10 days.
No. But it just is, I guess my question was really about time management, how you did
well, that. I mean, the early years at USC, I didn't sleep much. And I was in my office at 3 and 4 in the morning and didn't go home until fairly late at night, 7 days a week. And I remember when I fell in love with, I came to LA just to move my career along. And then both places I'd been to before, I stayed 6 years. I expected to stay 6 years at USC. And part of the reason I didn't go, I was too busy. And then we had a good group. But also in the early years, there was one Saturday when I couldn't do anything. I just wasn't getting anywhere. So I got in my car, I drove to Japantown, had some food, I just drove across the LA basin with no plan, no map, stopped here and there. I'm not a sports guy. I went into a bar and talked sports with some old guys. And it just dawned on me how marvelously complicated and heterogeneous the city was. And that was when I fell in love with LA. And that was another thing that kept me here those years.
So anyone else?
I do.
I,
Go ahead, Richard.
it's sort of maybe a simple question, but really a question of opinion. But one of my mentors when I first came to USC said that the the key to a successful academic career is a love of writing. That you're able to express what you're doing and be recognized for it. Did you find that true?
Absolutely. And, communicating to students that they're telling, students in science, they're telling a story. and one of my great mathematicians friend told me that we spend all of our times in the proofs of the theorem. And he said, 2 people will read that. He said, many people will read the abstract. Everybody will read the title. He said, and we allocate our time inverse to that. He said. And it really stuck with me. Again, it's storytelling, even though it might not look like a story to you. It's got to be. At one critical time, I was in Idaho, and my wife collapsed, and I wrote a couple of papers, and one of them, it's one of my favorite papers. It's never been cited. And I looked at it, it's still one of my favorite papers. I looked at it recently, along with being 10 or 15 years ahead of the time. I said what I was going to do, but I didn't say why it was cool. I didn't tell the story properly. And this is really, I think, really important.
And there was someone else who also.
No, you're such a distinguished professor. You understand a lot of things that we don't in terms of the biological sciences and that kind of thing. I'm wondering now, after your career, and now you have a little more time to focus on health and well-being. I know I'm doing a lot more reading and hearing from all these folks about the ways to stay healthy. What are your thoughts about staying healthy as you go into this next stage of life? Well,
trying to stay physically active, I think, is really key, but mentally active as well. And this transition, we were many of us driven in our careers, and now if I ever never publish another paper in my life, it's irrelevant whether I do or not. I feel really lucky to have landed here in Pasadena, next to Caltech, but in walking distance of 3 quite good playhouses, the Lemley Theater on Colorado, lots of places to eat, lots of coffee shops. So there's to get out and around in the world. And before COVID, I never appreciated walking down the street and saying hello to someone. And I walk for about an hour in the morning. I get up about 6 and walk an hour in the morning. So there's a certain number of homeless people I know. And over here, there's Kohl's or something where they have a lot of paper boxes out in front, and this Mexican guy puts them in his pickup and takes off. And we're friends. We say good morning, good morning. If he sees me walking and he's in his pickup, he honks. It's important. It's important part of my day, and I didn't realize this sort of thing counted for so much.
Wow.
So anyway, I'm still struggling with adjusting to all of this, but better than not adjusting, eh?
Yeah, but that's the just wonderful ways of spending your time already, I think. So is there anything that no one's asked you that you would really like to talk about?
Gosh,
it's kind of an unfair question, but I just thought, maybe you're thinking, when is someone going to bring this up?
No. Well, there's a story I want to tell that isn't quite what you asked, but when I was at Oregon State, I said I had this teacher, H.E. Childs. And I grew up in one of the remotest part of Oregon. It was homesteaded not until the 1890s. Electricity came when I was in fourth grade. There's another corner of Oregon, exactly the opposite, southeast corner, Steens Mountains and so on. And a guy named Bill Kittredge grew up there on a ranch.
Oh,
The great writer. And he has a novel that he wrote in his 70s, maybe, called The Willow Field. And it may not be quite a great novel, but it's a really good novel. And in it, he's got and it ranges from sort of Carson City, the Truckee River, up to the Bow River flowing out of the Banff in that area. And it's about horses and the West and so on. All of these facts that he knows shows up in there about how to handle the horses and the springs and the decline of the West. And I don't remember his name, but there was a Montana historian who saw that Montana was like a third world country where the resources are being extracted. And Kittredge fused that guy and H.E. Childs into a character in his book. And even there's a quote he has from H.E. Childs in one of his memoirs that he has the character saying. So I thought that was just a wonderful contribution to all of us to be able to put that down. I look forward to reading it again in a few years.
I have a question, Mike, about recent development at USC and the creation of a new department of quantitative and computational biology. And in many ways, you helped be the foundation for that. And I think you helped launch it administratively as well. Would you like to comment about it and its ranking? And
sure. Some years ago, I was on a board at Columbia, and one of my friends gave a talk, and I asked a question, and afterwards his postdoc came up to me, and it was Remo Rose. So we ended up recruiting Remo Rose, and who went from assistant to full professor. And Remo really saw the path of this group being in a section in biological sciences to becoming a section to becoming a department. And I've been a sounding board for him and a cheerleader, but I'm really happy this has happened. And I feel like this faculty that I had something to do with being here have their own future in their own hands now. And if they screw it up, it's on them. And if they do, and I don't think they will, but it really makes me feel very happy to see them in this state as I leave.
good. And any other questions, comments?
Richard, you've got you're muted.
Muted?
There.
Can you hear now?
Yeah.
So I'm wondering about the future of the field. And it's clear that people are using a lot of mathematics, and statistics is playing a big part of it. And of course, there's computer sciences of various types. And so I'm wondering, what is the secret blend of these, and how does artificial intelligence come in as you look to the future of the field?
Yeah, I remember the first meeting of RECOM in '97. Mostly statistics and computer science in the audience, and people were shocked when I had a biologist speak. And today, when I go to the same meeting these years, everyone knows more biology than I do at this point. So it's really it's been a fusion of statistics, mathematics, biology, and computer sciences, including AI, which is certainly not unrelated to statistics. Exactly how this will proceed in the future, how this amalgam will be organized and reorganized, I don't know. I try to imagine what an introductory biology textbook will look like 100 years from now. You can't memorize, today it's breaking because you can't learn long lists of everything that's known, which I claim used to be the model. So, how do you pull the principles out and let people dive deeper when they want to? Anyway, I would just love to see that educational program. So the answer is I don't know.
Anyone else with a question or comment? Wow, I think we've run out. Have we run out of ideas, thoughts?
I see a hand up.
Oh,
Greg.
good.
Yes, how are you, Mike? I have just a comment. First of all is that I miss our regular lunches in which you gave me tutorials about computational biology, about which I knew nothing. And that was always a wonderful experience, frequently every month or every couple of months. So I really miss that. And that has been very, very nice experience for me. So it's wonderful to see you.
Likewise.
Thank you.
Well, wonderful. I just want to thank you again, Mike. This has been great. It's been so interesting hearing from you, especially someone like me who's way outside that field, inspiring to me just how excited you continue to be about science and mathematics. It makes me very conscious of what I've missed, and the way that you also sort of put that in broader contexts of storytelling and being out in nature, I think is wonderful. So thank you very much, and thanks everyone for being here and taking part, and also to Jerry and Jeanette for all their work on this. Thank you very much.
Thanks, Mike. Excellent. Yay.
Thank you.
Thank you, Mike.
Thank you all.
Appreciate it.
Take care, everybody.